Now, the last thing I want to talk about, and this is kind of a big deal, uh, this finding the greatest common factor of numbers, or later on when we study polynomials, we'll be finding the greatest common factor of the terms in a polynomial. Um, that is kind of a useful thing, and often we will factor out the greatest common factor, and so we need to be able to figure out what that is to do that. Greatest common factors is just the number that's the biggest number that divides 2 or 3 or 4 or 10 numbers evenly. So here's a few examples. 24 and 32. The biggest number that divides both of those is the number 8. 24 divided by 8 is 3. 32 divided by 8 is 4. For 320 and 1,000, the biggest number that divides them both is 40. And 24 and 7, the biggest number that divides both of those is actually just a 1. 1 is the only number that divides both of those numbers. So sometimes those numbers are called relatively prime then. But anyway, how do we find these numbers? Well, there are two ways that you can find greatest common factor that I can think of off the top of my head. One is, well, let's just list all the factors of both numbers and look for the biggest number that's in both lists. That can be okay, but it also finds a whole bunch of numbers that we don't really need. Or another way is to use prime factorization. If we find the prime factorizations and multiply all the common prime factors, all the numbers that are in both factorizations, that also gets us the greatest common factor, and that can usually be done a little bit quicker. So that's the method I would suggest that you do. I guess I'm emphasizing it here with big font. So anyway, let's look at those specific examples we saw just a second ago, and we'll use both methods just to compare and contrast and see how they are. So 24, if you were to list all of its factors, there's 1 and 24, there's 2 and 12, there's 3 and 8, 4 and 6, and 5 doesn't work, and then I've got 6 and 4 again. So here's all the numbers, all the factors of 24. And then 32 has a bunch of factors too. I got 1 and 32, 2 and 16, and 3, nope, 3 doesn't work. 4 and 8 works. 5 doesn't work, 6 doesn't work, 7 doesn't work, and now I'm up to 8 times 4 again. So here's all the combinations that give us 32. And the biggest number that's in both of these lists, 1 is in both, 24, nope, 2 is in both, 8's in both. That looks like the biggest. The biggest number that's in both lists is 8, so 8 is the greatest common factor. So it wasn't too hard, but these numbers then again weren't really that big. Here, there's a lot more factors of 320 and a lot more factors of 1,000 than there were here, and so maybe this method isn't going to be quite as nice then. Let me show you the other method, finding prime factorizations of each of these. So 24, its prime factorization is one that we had found earlier, 2 times 2 times 2 times 3. That equals 24. 32, I know it's a power of 2. It's 2 to the 5th power, and so its prime factorization is pretty simple. It's just 2 times 2 times 2 times 2 times 2. 2 to the 5th. And if we look at these two prime factorizations and circle what they have in common, they both have 3 factors of 2 in common. So its greatest common factor then is whatever 2 times 2 times 2 equals. And 2 times 2 is 4, and 2 times 2 is 4 times 2 is 8. So its greatest common factor is an 8. That works every time. So let's look at 320 and 1,000. So I am not going to list all these factors because that's going to take a long time. But 320 is really not too much different than 32. That's 32 times 10. And 32, we already learned, was 2 to the 5th power. And 10 is just 2 times 5. And so there's the prime factorization of 320. Didn't take me long at all. 1,000, I don't know that one off the top of my head, but I do know that 1,000 is 10 times 10 times 10, and 10 is 2 times 5. So 2 times 5, 2 times 5, 2 times 5. Its prime factorization in order would be 3 2s and 3 5s. And if I were to look at both of these and circle what do they have in common, they both have 3 2s in common. And they also have at least 1 5 in common. And then from there on out, they're different. So the greatest common factor is what I get if I multiply 2 times 2 times 2 times 5. 2 times 2 is 4, times 2 is 8, times 5 is 40. So their greatest common factor is 40. Finally, the greatest common factor of 24 and 7. 24, remember, is 2 times 2 times 2 times 3. And 7 is just 7. That is its prime factorization. What do they have in common? Nothing. They don't have any numbers in common. So when that happens, its greatest common factor is just the number 1. Remember that 1 can divide anything. Anything can be divided by 1. And so both of these numbers can be divided by 1. In fact, that's it. And so that is its greatest common factor. So now, math teachers everywhere, except for me, will probably hate me for what I do next, because I'm also going to show you how to find greatest common factor on your calculator. I think math teachers kind of enjoy giving you guys these problems to do, to kind of exercise your brain, and so they don't want to just show you how to find it on a calculator, but just because it's there, and you ought to know, I'll get out my calculator again. Oops, looks like I shut it down, so bring it up here, and to find the greatest common factor on a calculator, it's very easy to do. Let me quit to get to the normal screen. And greatest common factor is hidden in the math menu. If you hit the math button, over to number, and then down in this list, there's an option here that says GCD. That's very close to GCF, greatest common factor. That's because in Texas they pronounce factor divisor, and so they use the word divisor instead of factor. Greatest common divisor is what the Texas Instruments Company has decided to call this function instead. But anyway, you can do greatest common divisor, and then list your numbers in order with separated with commas. So 24 and 32, the greatest common divisor of those two numbers is 8. And if I do the same thing, I'll go back to math, over to number, down to greatest common divisor of 320 and 1,000. I'm probably going to get all sorts of hate mail now on my YouTube account from Texans that happen to be watching, and they get all mad because I'm mocking their accent and divisor. Anyway, GCD of 320 times and 1,000 is 40, just like we calculated. And if we did this again with 24 and 7, you'd see that you get out a 1. So that's some basic ideas that we need when we work with polynomials later in our next video about common factors and prime factorizations and common divisors. So thanks for watching, and tune back in next time when we take advantage of these ideas again.